Hi students, last class I discussed about acceleration. Acceleration is nothing but change in velocity per unit time. Acceleration which is a measure of change in velocity of an object per unit time. In formula manner, we will write acceleration equal to change in velocity by time taken. So here change in velocity. So how we would represent that? Suppose if an object changes from initial velocity u to final velocity v in a time t. You can recall by an example which I discussed in the previous session. Suppose if you are starting, so that is your initial velocity. After certain time, you reach your maximum speed. So if that you can take as final velocity. Now in formula manner, acceleration A equal to V minus U by T. So this is the formula we will use to calculate acceleration of an object. So the SI unit of acceleration is meter per second square. Now this acceleration is positive or acceleration is negative and acceleration is 0. So what is the meaning of positive acceleration? What is the meaning of negative acceleration? We will do certain problems, then we can understand what is the positive acceleration, what is the negative acceleration. This is the NCERT example. See the question. A bus decreases its speed. So here the bus is decreasing its speed from 80 km per hour to 60 km per hour in 5 seconds. Suppose you want to stop a bus which is moving 80 km per hour. So what you have to do? You have to apply brakes. When you apply brakes, then the speed of bus is decreases. Now here we are having the two values. Since the bus is decreasing, so I'll take the initial speed or initial velocity. Initial velocity as 80 km per hour. Initial velocity u equal to 80 km per hour. Here itself try to convert into meter per second. So to convert kilometer per hour into meter per second, we need to multiply 5 by 18. 5 by 18 meter per second. If we can do this for the simplification, you can cut with the 9th table. Sorry, if you want cut with the second table, 9 2s are 18, 42s are, if you can do the simplified calculation, you will end up with 22.22 meter per second. So what's the value given at here in kilometer per hour? We converted into meter per second because acceleration units we will write in terms of meter per second. Similarly, if u is the initial velocity 80 km per hour, after applying brakes the velocity decreased, so that we will take as final velocity. Final velocity v equal to 60 km per hour as usual. So you convert this by multiplying with 5 by 18, in terms of meter per second. You cut with second table, 9 twos are 18, 32s are 15. You do further simplification, you will end up with a value. Its value is 16.66 meter per second. Now I will write the acceleration formula. Acceleration A equal to V minus U by T. Final velocity minus initial velocity. So here you can substitute the values of the final velocity is 16.66 minus U is 22.22. Both are meter per second divided by time, which is given 5 seconds. If you use calculator to solve, or you can use, so I can subtract from 16.66 minus 22.22 equal to minus 5.56 divided by 5. The answer is minus, so you can write the answer here, acceleration A equal to minus 1.112 minus 1.112 meter per second square. So this is the acceleration of the bus. So here, what is the negative sign indicates? The negative sign indicates the bus decreasing its speed. So when you move with 80 km per hour, then you apply brakes, automatically the bus will slow down. So the negative sign shows about the decreasing acceleration, which is also known as deceleration or negative acceleration. All words are same. Since the brakes are applied, the bus decreases its speed, automatically its acceleration also decreases. So this is the one of the example for negative acceleration. Let's see another problem. The problem is a train starting from a railway station. So it is starting. It is not moving initially. It is starting and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. We need to find its acceleration. So to find acceleration, I need three quantities. For acceleration, we need u, initial velocity, we need initial velocity, and we need final velocity, which represents v, and we need time. We need time t. So by using these three parameters, we can substitute acceleration A equal to v minus u by t in this formula. Now let us find the values in the given problem. First one, initial velocity u. The train starting. So common sense, if the train is starting, so initially the train is at rest. Since train is at rest. So initial velocity u equal to 0, and the train acceleration attains a uniform speed, attains a speed. So the value which is given at here, that speed is final velocity. Given final velocity v equal to 40 kilometer per hour. So we will convert this in terms of meter per second by multiplying 40 times 5 by 18 meter per second. If we multiply that, and you will get the value 40 times 5 by 18. You can cut down to table 9 times and the 20 times. If you can do the simplification, the answer you will get 11.11 meter per second. So this is the final velocity and time. So u equal to 0 and v equal to 11.11 meter per second, and time t equal to 10 minutes. Time t equal to 10 minutes. 10 minutes. So we will convert this into seconds. 10 times 60 seconds, which equal to 600 seconds. Now substitute these three values in the formula. Acceleration a equal to v minus u by t. So a equal to v, final velocity 11.11 meter per second, minus initial velocity which is 0, divided by 600 seconds. So you will end up 11.11 divided by 600 meter per second square. You do the simplification, so that you will get the final value. So we can get the final value at here 11.11 divided by 600, which gives the value 0.0185, which I can write at here. Acceleration a equal to 0.0185 meter per second square. Now see at here, this value is positive. Here nothing is there, it means here it is the positive. So how the acceleration is positive at here? Since the train is starting from rest and it is picking up speed. So if you're starting and picking up speed, so you have positive acceleration. Now, if you want to stop the train, it means you are already having certain speed. To stop the train, now you have to apply the brake. Now the train velocity decreases. So that time you will get the negative acceleration. So these are the two examples. So this is known as positive acceleration. So acceleration is positive and acceleration is also negative. I will discuss one more problem. So two cases together. Let's see this problem. The problem is, starting from a stationary position, Rahul pedal Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So here we are having the two cases. Let me take as case 1. Case 1 and case 2. What is the case 1? Starting. Case 1 is at here starting and case 2 at here after applies brake. So we know that from the given problem, starting from a stationary position. So precisely they are mentioning it's a stationary position. Stationary position means rest position. So we can take initial velocity u equal to 0 because starting. And final velocity v equal to Rahul pedals his bicycle to attain a velocity of 6 meter per second. The final velocity 6 meter per second and the time t equal to 30 seconds. So now you easily calculate the acceleration formula. A equal to v minus u by t, here v 6 and u 0 by time 30 seconds. So this is the meter per second and you can get a value 6 by 30 meter per second square. If you simplify this, you will get 6 by 30 equal to 0.2 times. So 0.2 acceleration A equal to 0.2 meter per second square. So this is the first case. So the acceleration is positive 0.2. Here there is no negative sign. Now after applies brakes, this is the second case. When he applies brakes, what happens? His bike speed decreases. Its bike velocity decreases. Now when he applied the brakes, when he reaches the velocity 6 meter per second, now that we will take as initial velocity. So in this case, initial velocity u equal to 6 meter per second. So at this velocity he applied brakes. So when we apply brakes to vehicle, what happens? The velocity decreases. So the decreased velocity we will take as final velocity. Final velocity v equal to how much it is? 4 meter per second. And how long he applied brake? Time t equal to 5 seconds. Now we got three values. You can substitute the three values in acceleration formula. A equal to v minus u by t. Final velocity v equal to 4 meter per second minus initial velocity u 6 meter per second time 5 second. If you can do this calculation, 4 minus 6, you will get minus 2 meter per second, and the denominator 5 second. So you simplify this one, and acceleration A equal to minus 0.4 meter per second square. So here the negative value is nothing but Rahul applied brakes. That's why his acceleration decreases. And in this first case, he is starting and he's keep on pedaling. So that's why here the acceleration is positive. Here nothing is there. Here means nothing but it's a positive acceleration. So that's why this is known as positive acceleration. And here negative acceleration. This is known as negative acceleration. This is known as negative acceleration. Which also known as deceleration and which also known as retardation. All three are same. Negative acceleration, deceleration and retardation. All are the same. So these are the two different cases when is acceleration positive and when is acceleration is negative.